This evaluation video is on my top-down shooter game. I've had 5 weeks to create based on Journey of the Prairie King arcade side quests in Stardew Valley, while utilizing various programming features, such as computational thinking modules, those being if-else statements, manipulating the Unity 3D renderer for materials, switch cases, and 1D arrays. Using abstraction, the key modules were identified from observing gameplay from my inspiration. Here on screen you can see the basic mechanics broken down into major modules. If and else statements are the bread and butter of most student games, something that is proven here, as well as it is used throughout almost every script used in my top-down shooter. But chosen to be my example was the movement system for my enemy prefabs. The enemy movement system utilizes the system collection's random.range function to repeatedly do a function that is called when the attached script objects appear in the scene. Each enemy prefab does 2 coin flips to decide whether the answer for an integer will be either 1 or 0, then deciding the speed value between half or same speed as the player, then also deciding on whether to move vertically or horizontally. The movement of the enemies being linear movement between 2 points, then changing direction when hitting one of the specified points. Ideally, this would be moving vertically for all enemies along the top and bottom edge, and vice versa horizontal for left and right, but this was a quick fix for movement that worked. For difficulty in my top-down shooter, a damage and health system needed to be implemented for the player, but after my first playtester asked to see how the player is taking damage, the change was made to make the player taking damage be a readable change on screen. During play without damage, the player is a pure green color, but after taking damage will flash blue 3 times, then temporarily become invincible to allow the player to escape from being trapped by enemies. This was done through temporarily changing the RGB brackets 1, 1, 1, 1, close brackets, values of the player's material to blue being open brackets 0, 0, 1, 0.5, and back to green being open brackets 0, 1, 0, 1, close brackets. Using the renderer and a coroutine known as damage frames, as well as implementing a health bar through a UI image of a line of pixelated hearts that shrink to show less hearts with each section of damage taken. Switch cases are used with enum statements to change a lot of local variables without using endless nests of if and else statements. Cases are the results of the search made by the switch. If you have an enum with 4 variables, a switch will likely have 4 cases, 1 for each variable within the enumerator. While switches can theoretically take infinite cases and select the correct case, it is hardware intensive to be well utilized within a script. In my top-down shooter, the major use of switch cases is with my weapon switching script. Each weapon has local variables to change the feel and look of the weapon, those variables being damage, fire rate, weapon game object, bullet spawning position, current amount of ammunition, and maximum amount of remaining ammunition. This uses the weapon controller and the weapon switching scripts, where through the enum weapon type, it can be switched through pressing keyboard button E to cycle through all the available weapons. These are intended to be used strategically. With top-down shooters, most notable examples spawn enemies from all sides to move along the gameplay window and attack the player through the enemy's spawner script. This script uses a coroutine called spawn wave to spawn enemies for a wave through adding instantiating prefabricated enemies into the scene until it counts to the correct number of enemies in the wave, on all sides, which means each wave adds 4 enemies to increase difficulty. These prefabs all contain in the script enemy and are treated as variables to be added into the list enemies alive. When each enemy is dealt enough damage by the player, they are all then erased from the array, thus counting the round as being over and starting a new round through respawning enemies. These arrays make it simple to check if all enemies in a scene are dead and simplify how to run rounds within the game, though it makes the difficulty of each round scale higher in a linear way. My top-down shooter, while being simple in art style and concept, requires good understanding of the C# programming language, utilizes many features to show my ability in programming and developing under time constrictions, while also showing my computational thinking in problem solving. This project demonstrates astute innovation and computational thinking through its game mechanics and its ability to be packaged for local play.